quite literally, and we'll talk about how we're going to do that. Our project, should we choose to accept it, is to construct a trackable weather balloon carrying the world-famous Dave's hammer to lower Earth atmosphere. So how will this work? This is kind of a rough kind of clip art of how the weather balloon system works. We have our weather balloon carrying up our parachute that's in tension with our payload underneath it. Once we get to altitude and the weather balloon expands because of the pressure difference, it will pop, and then the parachute would no longer be in tension, and it will deploy and will slowly come back down to the ground, and that's when we're going to be able to get our weather balloon back. Then we'll have a pretty great story, and as well as cool pictures to post around the Makerspace of the hammer that hundreds of mechanical engineering students have made. They'll get a little bit more pride behind the hammer that they're making in the manufacturing class. So here are our rough specs. More to come soon. So we have $1,000 allocated purely for this project. Our targeted height is around 80 to 100,000 feet. So we're gonna get the 600-gram weather balloon. Lifting gas, we are using helium. We're not gonna do hydrogen. Even though hydrogen's much cheaper, helium is far safer. We're targeting launch date for April 9th. Now this is gonna kind of be really key. We want to stick as close to this schedule as possible because April 8th is our eclipse day, so we want to launch it. I believe the total blackout eclipse in this area is 9:24 a.m. So we have to be out on launch site. We're still trying to figure that one out. We want to be out in a rural area, so when it does come down, we're going to hit a field and not a poor civilian somewhere on the road. The great part about this project is we not only get to build something cool and do something amazing that no one at UTSA has done before, even though it's been attempted, but we're gonna follow through, is we learn a lot about aerospace and kind of the upper atmosphere and how all that works, the weather conditions. So one thing you've noticed, these are just all grabs from the internet of typical payloads for the weather balloons. They're all styrofoam. Now, it is a great insulator. However, we're the Makerspace, so we could do a little bit better than a cheap $15 insulated cooler. Well, 3D printer on that makes it a whole lot easier. We can design whatever we want. I don't know, maybe a stuffed rowdy inside or something, a little compartment for that. This little hammer sticking out from the payload, and this is the hammer altogether weighs about 6 pounds, branding. So of course, if we print it out, we can't just do a basic box. Dr. Peterson is a big avid believer on not doing basic boxes and go all out. We have the Makerspace. We got to use its resources and show everyone what we're capable of doing. So what's next? We got to hash out the electronic components and order materials. What we're going to cover for next meeting is the specs of components. So once we hash out everything, we want to give more detailed specs for everything. And then also we'll go over our whole extensive FAA regulations. There's going to be quite a few. And hopefully this is what we're going to accomplish here April 9th, something similar to that. So we'll have our hammer sticking out with the Earth in the background. That's what we're striving for. That's what we're hoping to get on a big poster plastered all over the Makerspace. Thank you. That concludes kind of the first general meeting for the brass balloon project. We'll have a second one coming soon. I'm Jacob, and you're watching Makerspace Mondays.